we have been discussing a lot about the rise of LLMs, why LLMs have been really successful, right? So that whole revolution actually came down to this model called transformer model. And today I'm going to be discussing a little bit about transformer models and why they have created that sort of revolution. So one of the biggest advantages of the transformer model is that it comes with a pre-training, right? It means that you can actually train your transformer model on general data, right, which is unsupervised in nature. And not only that, because you can train billions of parameters with this unsupervised data, it is possible for us to get a very high level of accuracy as well as generic knowledge and performance, which is not tied to a specific field or a specific action, which used to be the case earlier on for the different machine learning models that we used to have, because most models used to be very good at doing something specific, whereas because of the pre-training and the large number of parameters, the whole transformation has happened with transformer models because of the fact that now they have become more generic rather than more specific. So the transformer model has three main aspects to it, right? So there is first tokenization and embedding layer, right? So what happens is that when you have any language input, like a sentence, for example, right, this is broken down into tokens, right? The tokens usually are invariable versions of a word. So in English, most words are a token. Maybe some punctuations, they are tokens too. But there are other languages where the words can be combined, like German, for example, right? They can be combined together. So then one word may be made of more than a few tokens, right? So, but in English too, there can be some words which have token, which is like a joint word, or a word which has which is created out of combining more than one word, right? So the tokenization is the first step. Then we convert these words, these tokens, to a vector representation. So each token is represented by an array of numbers, and there are different embedding systems which they call, as they call it, which converts any token to a representation of a vector, and this is what is the basis of all the learning that has happened in LLMs so far. So once we have the embeddings, then the second aspect that comes to the fore in case of the transformer models is the attention mechanism. So what is the meaning of attention, right? So when we say any sentence, right, there are several meanings attached to the sentence. So firstly, it could be something simple as when I say that he ate an apple, right? And what it would mean when I say he ate an apple could make a lot of difference based on the context. So for example, if I say that he ate an apple, it could be that he ate an apple instead of eating an orange, or instead of eating a banana, for example, he could say that, right? Or if somebody was told to stand with the apple, or serve the apple to someone else, and from a basket of apples, this guy took and ate an apple, right? It has a completely different meaning to it, right? And there could also be things like, so instead of cutting the apple, he ate it, or instead of serving the apple, he ate it, right? So the meaning or the context plays a lot of importance in what words we give attention to, right, when we listen to a sentence. So this is a simple sentence like he ate an apple, which can only have possibly two particular contexts. But as the more complex sentences that are there, depending on all the contexts that may have occurred before that sentence, there could be many different ways to interpret that sentence, many different meanings that the sentence could actually bring to us, right? And this actually was a breakthrough in the transformer model, which was the ability to provide attention to the sentence, right? So you can so basically an attention model is also a neural network, just like the other parts of the transformer model, embeddings, etc. So it's also a neural network, but the idea is that you create a combination of three, which is a query, a key, and a value, right? So query is the query that you want to ask about the sentence that you are trying to focus on, or you're trying to learn, right? So you're saying what is special about this particular sentence. So you could, for example, say that the cat sat on a mat and the word cat and sat, they are more relevant. So you want to identify which is the object and you want to identify which is the verb. So you can have one query which is asking you which is the object. You can have one query which is telling you which is the verb, right? So these are short-term relationships. Similar to this, you can have other queries which can set up a context to say that, okay, is the cat relevant to the story? Is it a new character that is getting added to this, or is the cat that we are talking about already existent, and we are sort of putting that in the context of the question that the cat sat on the mat, right? And so these queries then get converted to keys, right? Which are these keys are the ones which we encode, and for each query and key we are then able to identify a value which gives it the attention. So every sentence we can have an attention value, or every token within the sentence can be attributed an attention value by doing a dot product of the key query and the key. So both the query and the key are encoded as vectors 2, and a dot product is their value, which is what is assigned to an attention for a specific query. So this is taken to a completely different level now, where we can have multi-headed attention, which means that we can provide attention to we can provide such kind of queries and provide attention to different aspects, and it can be long-term, short-term kind of queries. It can be about the subject, it can be about the action, it can be about the type of language, it can be about the emotion that is associated with it, it can be about so many different things, right? So our language is so multi-layered, and hence we require multiple heads of attention, which then allow the language model, or the transformer in this case, to learn different aspects of every training data that it receives. So let's put it together. So after we do a tokenization, and then we do an embedding, and then we have a multi-headed attention, and after the multi-headed attention we have a feed-forward network, which is a typical kind of network which has been used in the past for a neural network, right? So it's a deep neural network, and at these different layers together have really caused the evolution of LLMs, and we are where we are today.